Then we discuss money, prices, and exchange rates in the long run. Money market equilibrium. In a simple model, in the long run, the exchange rate is determined by the ratio of the price levels in two countries. But this promotes a question. What determines those price levels? Monetary theory supplies an answer. In the long run, price levels are determined in each country by the relative demand and supply of money. This section recaps the essential elements of monetary theory and shows how they fit into our theory of exchange rate in the long run. Economists think of money as performing three key functions in an economy. Money is a store of value because it can be used to buy goods and services in the future. If the opportunity cost of holding money is low, we will hold money more willingly than we hold other assets, and etc. Money also gives us a unit of account in which all prices in the economy are quoted. Money is a medium of exchange. Money is a medium of exchange that allows us to buy and sell goods and services without the need to engage in efficient barter. Direct swap of goods. Money is the most liquid asset of all. What counts as money? Clearly, currency in circulation is money. M0 is typically latest definition of money, and it includes both currency in circulation and the reserves of commercial banks. M1 includes currency in circulation plus highly liquid instruments such as demand deposits in checking accounts and traveler's checks, but it includes banks' reserves. M2 include slightly less liquid assets such as savings and small time deposits. So in this book, when we speak of money donated M, we will generally mean M1. Figure 3.4 shows the major kinds of money aggregate. Currency, M0, M1, and M2 for the United States from 2004 to 2010. Normally, bank reserves are very close to zero, so M0 and currency are virtually identical. But reserves spiked up during the financial crisis in 2008 as private banks sold securities to the Fed and stored up the cash proceeds in their Fed reserve accounts as precautionary hoard of liquidity. How is the supply of money determined? In practice, a country's central bank controls the money supply. In our analysis, we make the simplified assumption that the central bank's policy tools are sufficient to allow it to control indirectly. But accurately, the level of M1. A simple theory of household money demand is motivated by the assumption that the need to control transaction is in proportion to an individual's income. We can infer that the aggregate money demand will behave similarly. All else equal, a rise in national dollar income will cause a proportional increase in transactions and hence in aggregate money demand. A simple model in which the demand for money is proportional to donor income is known as the quantity theory of money. Demand for money is equal to a constant times nominal income. M superscript D is equal to L bar times Py. Dividing the previous equation by P, derive the demand for real money balances. MD over P is equal to L bar times Y. M superscript D over P is equal to L bar times 1. Real money balances are simply a measure of the purchasing power of the stock of money in terms of goods and services. The demand for real money balances is strictly proportional to real income. The condition for equilibrium in the money market is that the demand for money MD must equal the supply of money M, which we assume to be under the control of the central bank. Impose this condition on the last two equations. We find the nominal money supply equals the nominal money demand, and equivalently, that real money supply equals real money demand. An expression for the price levels in the US and Europe is PUS is equal to MUS over LUS bar times YUS. PEUR is equal to MEUR over LEUR bar times PEUR is equal to MEUR over LEUR L bar EUR times YEUR. P sub US is equal to M sub US over L bar sub US times Y sub US. P sub EUR is equal to M sub EUR over L bar sub EUR times Y sub EUR. The two equations are examples of the fundamental equation of the monetary model of the price level. In the long run, we assume prices are flexible and will adjust to put the money market in equilibrium. In Figure 3.5, the money supply and real income are treated as no exogenous variables. The model uses these variables to predict the unknown endogenous variables, which are the price levels in each country. Plotting the expression for the price level in the monetary model to equation 3.1, we can use absolute PPP to solve for the exchange rate. So exchange rate is equal to ratio of price levels equal to relative nominal money supplies divided by relative real money demands. This is the fundamental equation of the monetary approach to exchange rates. The implications of the fundamental equation of the monetary approach to exchange rate are intuitive. Suppose the US money supply increase, all else equal. The right-hand side increase. The US nominal money supply increase relative to euro cause the exchange rate to increase, mean the US dollar depreciation against the euro. Now suppose the US real income never increase, all else equal, then the right-hand side decrease, mean the US real money demand increase relative to euro cause the exchange rate to decrease, mean the US dollar appreciates against the euro. The US money supply is MUS and its growth rate is MUUS. So MUUS at time t is equal to MUS at time t plus 1 minus MUS at time t over MUS. This is the rate of money supply growth in US. MUUS at time t is equal to the rate of money supply growth in US. The growth rate of real income, GUS. GUS at time t is equal to YUS at time t plus 1 minus YUS at time t over YUS attempt T. This is the rate of real income growth in US. So GUS attempt T is equal to the rate of real income growth in US. Putting all pieces together, the growth rate of PUS is equal to MUS over L bar US times YUS equals the money supply growth rate MUS minus the real income growth rate GUS. We have already seen that the growth rate of PUS on the left-hand side is the inflation rate PIUS. Then we know that PIUS attempt T is equal to MUS attempt T minus GUS attempt T. The denominator of the third term of equation 3.3 represents the European price level. PEUR is equal to MEUR over L bar EUR times YEUR, and its rate of change is calculated similarly. Pi EUR at time t is equal to mu EUR at time t minus GEUR at time t. When money growth is higher than real income growth, we have more money chasing fewer goods, and this leads to inflation. Comparing equation 3.4 and equation 3.5, we can now solve for the inflation differential in terms of money fundament and finish our task of computing the rate of depreciation of the exchange rate. Rate of depreciation of the nominal exchange rate is equal to the inflation differential and is equal to differential in nominal money supply growth rate minus differential in real output growth rate. The intuition behind equation 3.6 is as follows. If the United States runs a looser monetary policy in the long run, measured by a faster money growth rate, the dollar will depreciate more rapidly, or else equal. If the US economy grows faster in the long run, the dollar will appreciate more rapidly, or else equal. If the United States runs a looser monetary policy in the long run, the dollar will depreciate more rapidly, or else equal. For example, suppose Europe has a 5% annual rate of change of money and a 2% rate of change of the real income. Then its inflation would be the difference, 5% minus 2% equals 3%. Now suppose the United States has a 6% rate of change of money and 2% rate of change of the real income. Then its inflation would be the difference, 6% minus 2% equals 4%. And the rate of depreciation of the dollar would be US inflation minus European inflation, 4% minus 3% or 1% per year.